In November of 2000, Congress enacted the Transportation Recall Enhancement Accountability and Documentation Act. This act is commonly referred to as the TREAD Act. Congress amended this act in June 2002. The amendment requires automobile manufacturers to incorporate a warning system in each new motor vehicle to indicate to the driver when a tire is significantly underinflated. The Act further defined that the system must provide notice when any of the 4 tires have a tire pressure that is 25% or more below the vehicle recommended tire pressure. The TREAD Act defined that the driver must be notified when the tire pressure of any tire is 25% or more below the recommended tire pressure. There are 3 categories of tire pressures. Tires can either be overinflated, underinflated, or inflated correctly. Click each type of tire condition to learn more. When you have finished, click Next to continue. A tire that is overinflated has a tread pattern where only the center portion of the tire tread touches the ground. Overinflated tires have a tire pressure that is set 25% or more above the recommended tire pressure. Tires that are overinflated will wear unevenly and, therefore, reduce the overall life of the tire. Because the tire is overpressurized, generally the driver will experience a rougher ride. This is because the sidewall of the tire is not able to flex as much to absorb going over bumps in the road. A tire that is underinflated has a tread pattern where only the outer surfaces of the tire tread touch the ground. Underinflated tires have a tire pressure that is set 25% or more below the recommended tire pressure. Because only the outer edges of the tire are touching the ground, the tire may overheat. The distance required for braking also increases. Due to the added pressure that is applied to the outer edges of the tire, underinflated tires have a shortened life. This tire condition also has a greater potential for blowouts because of the added forces applied to the sidewalls when driving over bumps in the road. A correctly inflated tire has a tread pattern where the full tire tread surface touches the ground. The tire pressure is set to the recommended tire pressure. When a tire is correctly inflated, the driver will experience the best ride comfort and obtain better gas mileage when compared to an underinflated tire. From a performance aspect, properly inflated tires will make the vehicle more stable when maneuvering. They also reduce the braking distance required when stopping. A tire pressure monitoring system, or TPMS, is a vehicle warning system designed to prevent unsafe situations caused by low or a loss of tire pressure in any of the tires. The TPMS monitors the tire pressure. It notifies the driver of the need to check tire pressure if the pressure falls 25% or more below the recommended tire pressure. All vehicles are equipped with a warning indicator lamp that illuminates when the driver needs to take action. Some vehicles provide an electronic readout of individual tire pressures. Since the enactment of the TREAD Act, manufacturers have developed more advanced ways of monitoring tire pressure. 2 types of TPMS exist. The system can either be indirect or direct. Click each type of TPMS to learn more. When you have finished, click Next to continue. The indirect TPMS was an early way to monitor tire pressure. This system used the existing ABS components to monitor the pressure of the wheels. Based on the wheel speed of each wheel, the ABS and TPMS control modules could detect and calculate the difference in tire diameters. Using that data, the system could determine approximate readings on the status of tire pressure. Based on updates made to the TPMS section of the TREAD Act, this system did not meet all of the requirements. Many manufacturers upgraded to the direct systems found in vehicles today. Direct TPMS are systems currently used in all recent model year vehicles. This type of TPMS utilizes pressure sensors installed on the inside of each of the tires. These sensors monitor the tire pressure and will notify the driver with a warning light if the tire pressure falls below the required limits. Direct TPMS exists in two different versions, either highline or lowline. These versions differ based on whether or not they provide the driver with wheel position detection. A direct TPMS is designed to monitor the tire pressure of the individual tires. This type of TPMS consists of pressure sensors, receiving antennas, a TPMS control module, a dash indicator light, and a reset set switch. Click on each direct TPMS component to learn more. When you have finished, click Next to continue. The tire pressure sensors used in a direct TPMS detect and transmit air pressure and temperature readings to a TPMS control module that processes the information. Tire pressure sensors can be either valve-mounted or band-mounted. Valve-mounted sensors are mounted to the rim using threaded metal valve stems. Band-mounted sensors are secured to the surface of the rim near the valve stem using a large band clamp. The number of receiving antennas found in a direct TPMS depends on whether the system is a highline or lowline version. A low-line direct TPMS will have a central antenna that is responsible for receiving all of the signals transmitted by the wheel sensors. This antenna transmits all of the sensor data to the TPMS control module for processing. High-line direct TPMS have individual receiving antennas located inside of each wheel well. Each of these antennas detects the closest wheel sensor and transmits sensor data to the TPMS control module for processing. The TPMS dash indicator light will illuminate on the dash display or vehicle information display if a concern is identified with a TPMS circuit. Depending on the type of direct TPMS, the indicator may or may not provide a display of the individual wheel that has low air pressure. Shown here are three different types of indicator lamps. The lamp on the left indicates a TPMS malfunction. The center lamp indicates that low pressure is detected but does not identify the affected wheel. The right lamp also indicates that low pressure is detected. This lamp also identifies that the front passenger wheel is the affected wheel. The reset set switch recalibrates or resets the TPMS whenever a driver or technician makes a change to a tire on the vehicle. The reset set switch may be a separate switch located on the dash or in the glove box. Some vehicles incorporate the switch with the buttons found on the steering wheel or vehicle information display. The TPMS control module receives the sensor data from the receiving antennas. It processes the data to determine if there is a concern with the air pressure in any of the tires. The control module compares sensor data against reference values stored in the module's memory. This comparison enables the control module to identify discrepancies or faults. If faults are found, the module communicates with the instrument cluster control module. The system will illuminate an indicator light notifying the driver of a concern. Now that you have become familiar with the types of TPMS and the components used to detect tire pressure, let's take a look at how to initialize and calibrate the indirect TPMS. Click each of the tabs to learn more. When you have finished, click Next to continue. Usually, the system has to be calibrated and initialized after a tire has been replaced, repaired, or filled with air as a result from a TPMS warning. Before starting the calibration process, you should adjust tire pressures in all tires. Set the tire pressure to the vehicle's recommended pressure. As a reminder, tire pressure should be set when the tire is cold, meaning it is at ambient temperature. After all of the tires are set to the vehicle recommended tire pressure, start the process by cycling the ignition. Using the key, turn the ignition to on, leaving the engine off. This will initialize the vehicle's control modules and power up systems used for calibrating the TPMS. Locate and depress the Reset Set button. This button could be located on the steering wheel or vehicle information display. In some vehicles, this button is located under the dash near the OBD diagnostic port or in the glove box. Depressing the Reset Set button will start the TPMS calibration. When the TPMS resets, the system begins to monitor the wheel speeds. The system informs the driver that it is in calibration mode because the indicator light on the dash will begin to flash. Perform a test drive of the vehicle while the system is monitoring the wheel speed sensors. You should drive the vehicle for approximately 10 to 30 minutes. During this drive, the control module will receive and process signals sent by the sensors and establish a new baseline reading. When the TPMS finishes its calibration, the system notifies the driver. This notification could consist of a chime, the TPMS indicator lamp turning off, a completion message, or any combination of these options. Now that you have become familiar with the indirect TPMS initialization and calibration, let's take a look at how the indirect TPMS monitors the tire pressure and notifies the driver. Click each of the tabs to learn more. When you have finished, click Next to continue. An indirect TPMS utilizes the anti-lock brake system, or ABS, wheel speed sensors to monitor the speed of each wheel as the vehicle is driven. As the vehicle is driven, the wheel speed sensors send pulses to the ABS control module. The frequency and amplitude of pulses sent to the control module depend on how fast the vehicle is going. The system generates pulses when the tooth gear in the vehicle's ABS passes by the wheel speed sensor. Each tooth that passes by the sensor generates a pulse. Consider two same-size tires with different air pressure readings. A tire with a lower air pressure reading will have a reduced tire diameter. Therefore, the smaller tire will rotate at a faster speed than the tire with a higher air pressure reading. The indirect TPMS works by detecting the differences in pulses sent by individual wheel speed sensors. If one of the tires had a lower air pressure reading than the other three, it would generate a higher frequency signal at the wheel speed sensor. All of the individual ABS wheel speed sensor settings transmit to the ABS control module. This control module processes the wheel speed data and looks for discrepancies. Only significant differences between the pressures in the tires would alter the signal enough for a discrepancy to appear. If all tires were underinflated but similar in tire pressure, the TPMS would not be triggered. This limitation is one of the key elements updated in the direct TPMS. As the ABS control module processes the signals sent from the wheel speed sensors, it detects the higher frequency of signals coming from the tire with the low air pressure. Once the control module detects a suspected issue with the tire pressure, it notifies the driver. The control module sends an output signal that illuminates a dash-mounted warning indicator light. Now that you have become familiar with the indirect TPMS calibration, initialization, and monitoring, let's take a look at how to initialize and calibrate the direct TPMS. Click each of the tabs to learn more. When you have finished, click Next to continue. The steps required to initialize and calibrate the direct TPMS are similar to those used on the indirect TPMS. The main difference is that the direct TPMS are usually reset during the menu options displayed in the vehicle information area. Some direct systems may also use a dedicated reset button. Before starting the calibration process, ensure that you set the tire pressure in all tires to the vehicle's recommended pressure setting. Then, using the buttons on the steering wheel or on the vehicle information display, access the tire pressure monitoring menu. Locate the command that will reset the system and recalibrate the stored values in the control module's memory. Once the TPMS reset calibration prompt is located, depress the Reset button. This will start the calibration of the pressure sensors. The Reset Set button may be located on the steering wheel, vehicle information display, under the dash, or in the glove box. Now in calibration mode, the TPMS will begin to monitor the individual wheel pressure sensors. Generally, the vehicle information display will inform the driver that the TPMS is monitoring sensors by displaying a message. Vehicles equipped with a Highline TPMS may inform the driver by displaying blank readings on the individual tire pressures. While the system is monitoring the tire pressure sensors, test drive the vehicle. You should start the vehicle and test drive it for approximately 10 to 30 minutes. During this drive, the control module will receive and process signals sent by the sensors. Using the sensor data, the control module can establish a new baseline pressure reading. When the TPMS finishes its calibration, the system notifies the driver that the calibration is complete. This notification may consist of a chime or the TPMS indicator lamp turning off. The driver could also see a completion message in the vehicle information display or the displaying of individual tire pressure readings. Now that you have become familiar with the direct TPMS initialization and calibration, let's look at how the direct TPMS monitors the tire pressure and notifies the driver. Click each of the tabs to learn more. When you have finished, click Next to continue. Individual tire pressure sensors monitor the pressure inside the tire. In regular intervals, the sensors transmit data about the air pressure and air temperature. Interval time varies by manufacturer. Usually, the sensors send out packets of data once every minute. When a significant loss of pressure is detected by the tire pressure sensor, it will usually increase the frequency of the transmissions sent to the TPMS control module. The transmission signals sent by the tire pressure sensors are picked up by a receiving antenna located inside the vehicle. Low-line direct TPMS have a central antenna responsible for receiving data from all of the sensors. Highline direct TPMS have individual receiving antenna. These antennae are located inside the vehicle's wheel wells and receive transmissions from the individual tire located below it. If the antenna receives multiple signals, it determines which signal is strongest and passes that one along to the control module. Once the signals are picked up by the receiving antenna, they travel onto the TPMS control module for processing. The control module monitors the tire pressures and compares the data against the stored baseline in the module's memory. The transmissions coming from the tire pressure sensors occur frequently. This allows the system to quickly notify the driver if the pressure within a tire falls below the specified threshold. If the TPMS control module detects a tire pressure that has fallen below the specified threshold, the control module sends a signal to illuminate the vehicle information display warning lamp. Some TPMS may also display text in the vehicle information area. Highline TPMS utilize an individual receiving antenna in each of the wheel wells. These types of TPMS are able to identify the location of the tire with low pressure. When a Highline TPMS informs the driver of a tire pressure concern, the driver also receives location information for the tire. Shown on screen are a few examples of driver notifications on vehicles equipped with a Highline TPMS. This module covered the characteristics and operation of tire pressure monitoring systems. First, you were introduced to the TREAD Act and the various types of tire inflation, including the definition of a TPMS. Next, an explanation of the various components that are included in direct TPMS were provided. Finally, an explanation of how both the indirect and direct TPMS operate was covered. In the second lesson of this module, you were exposed to the differences between a low-line and high-line TPMS. This lesson explained that highline systems have individual receiving antennae that accept data from pressure sensors and can provide the driver with information on each affected tire.